Stars aren't simply crushed by black holes. Instead, they undergo a gradual disintegration, a process driven by the black hole's immense stretching force. This isn't about sudden violent destruction. It's more like a slow, rhythmic unraveling of the star's internal structure. In the energy filament theory, when a star gets close to a black hole, the first thing it encounters isn't a sudden force pulling it in, but rather a drastic slowing down of time itself. The particles on the star's outer layers start to lose sync with those in the core, creating a situation where the outer layers slow down while the inner layers continue at their normal pace. This differential causes the star to experience a kind of rhythmic tearing. To help visualize this concept, imagine an orchestra that suddenly splits in half. One section is forced to slow down, while the other keeps playing at its normal pace, leading to complete chaos within moments. The star isn't being torn apart abruptly, but is instead being gradually dismantled, with the internal and external clocks running at different rates. According to the energy filament theory, the death of a star near a black hole happens in 3 distinct stages. The first stage is the collapse of rhythm. As the star moves closer to the black hole's outer critical boundary, the tension becomes sharper and the time differential increases. The particles on the surface and in the core begin to vibrate at different speeds, and the equilibrium of the stars starts to break down. Much like a building collapsing slowly due to external pressure, the star's internal structure begins to disintegrate, almost as if the forces acting on it are stretching and pulling it apart in a slow-motion collapse. The second stage involves the stretching of the star's shape. As the star approaches the black hole, it falls deeper into a gravitational slope. Imagine a snowball sliding down a hill. At first, it remains intact, but as the sloping steepens, the ball starts to lose its shape. Similarly, as the star moves closer to the black hole, its spherical shape is distorted and stretched into a long, thin strand of plasma. This stretching isn't a violent tearing but a gradual pulling to the point where the star can no longer hold its shape. It's like being stretched beyond the limits of its structural integrity. The third and final stage is when the plasma strands enter the black hole's destruction zone, known as the smashing zone. At this point, the stable rhythms of the particles are utterly shattered. The particles that once held together as a star are broken down into individual energy filaments, much like a strand of light being split into even finer beams. These energy filaments are then pulled into the core of the black hole, where they become part of its ever-active, boiling interior. The death of the stars isn't a sudden explosion, but rather a step-by-step process of rhythm collapse, stretching, and disintegration. The black hole doesn't just swallow the star as a whole, it breaks it down into a form it can understand, transforming the star's substance into energy filaments. The end of the star is not marked by darkness but by its conversion into filaments that are then absorbed into the deep, relentless boiling energy of the black hole. In the next episode, we'll move into Season 6, where we'll explore how do black holes create the illusion of dark matter. Tap follow, share it on New Physics, Clear Universe.